Okay, let's have a look at the chain rule. Now we know how to differentiate expressions like y equals 5x to the power 4 plus 8x cubed minus 3x squared plus 5x plus 11. To do that, we get dy by dx is, now 5x to the power 4 gives 4 times 5x to the power 3. 8x to the power 3 becomes 3 times 8x to the power 2. Minus 3x squared becomes 2 times 3x. 5x becomes 5 and 11 disappears. And we can simplify that if we want to. However, if we want to differentiate expressions with brackets, we first have to get rid of the brackets. So if we'd had in the past one like y equals x minus 3 into x minus 6, we first have to get rid of the brackets. Y equals x squared minus 6x minus 3x plus 18, or to simplify it, y equals x squared minus 9x plus 18. And then we can differentiate it. So dy by dx, when you differentiate x squared, it's 2x, and when you differentiate minus 9x, it's minus 9. So dy by dx is 2x minus 9. Now, in some situations, this can be very long, and we need to find a quicker way. So, suppose we want to differentiate y equals 3x plus 5 all cubed. If we expand the brackets, you first of all have to expand one pair of brackets. So we're left with 3x plus 5, and then we expand 3x plus 5 squared, which is 9x squared plus 30x plus 25. And then we have to expand those brackets. And that gives us 27x cubed plus 90x squared plus 75x plus 45x squared plus 150x plus 125, which does simplify a bit to y equals 27x cubed plus 135x squared plus 225x plus 125. Now we can differentiate it. So we have dy by dx equals, now 27x to the power 3 becomes 3 times 27x to the power 2. 135x squared becomes 2 times 135x. 225x becomes 225, and the number 125 becomes 0. So dy by dx is equal to 81x squared plus 270x plus 225. Now there is a quicker way to do questions like the one we've just done using what's called the chain rule. Now the chain rule says dy by dx equals dy by dz times dz by dx, where z is another letter. Here we see the differentials cancel just as if they were fractions. If these were fractions, we could cancel the two dz's and we would have dy by dx. Now, let's start with the question y equals 3x plus 5 all cubed. Now, we can let z equal the bracket 3x plus 5. So we don't actually need to put the brackets in. Z is equal to 3x plus 5. Now, we can differentiate that. We're differentiating z, and the letter that we're differentiating is x. So dz by dx equals 3. Also, we have y equals z cubed, and we can differentiate that. So y is the thing we're differentiating, and z is the letter that is being differentiated. So dy by dz is 3z squared. Now we know dy by dx is dy by dz times dz by dx. So dy by dx is 3z squared times 3. Now, z is actually the bracket, 3x plus 5. So, dy by dx is equal to 3, the bracket, 3x plus 5 squared, times 3. And so, that's equal to 9 into 3x plus 5 squared. Now, that's our answer. It is actually the same as the answer we had before, but we've still got some brackets. If we wanted to, we could expand those brackets. So 9 times 3x plus 5 squared is 9 times 9x squared plus 30x plus 25, which is equal to 81x squared plus 270x plus 225, which is the answer we had originally. Let's have a look at another example. This time let's differentiate y equals, in brackets, x squared plus 5x minus 3 all to the power 8. Now, if we wanted to expand these brackets, it would take a very long time indeed. However, with the new method, we can differentiate this quite quickly. So let's see how we solve it. First, we have the chain rule. dy by dx equals dy by dz times dz by dx. Now, let z be everything inside the brackets. So z is x squared plus 5x minus 3. Now if we differentiate that, we're differentiating z, but the letter that we're differentiating is x. So dz by dx is, now x squared becomes 2x and 5x becomes 5, minus 3 disappears. So dz by dx is 2x plus 5. Now, we've got y is equal to the bracket to the power 8. So y is equal to z all to the power 8. And if we differentiate that, dy by dz is equal to 8 times z to the power 7. Now we've got dy by dx is dy by dz times dz by dx. So dy by dx is 8z to the power 7 times, in brackets, 2x plus 5. But we can't leave z in our answer, so we need to change z back into x squared plus 5x minus 3. So dy by dx is 8 into x squared plus 5x minus 3 all to the power 7 times 2x plus 5. Now we can write that dy by dx is 8 into 2x plus 5 into x squared plus 5x minus 3 all to the power 7. And that is the chain rule. Now actually, I even shorten it down quicker than that. I call it the brackets rule. If they ask you to do a question showing the chain rule, you should write it out in full, like example 2. However, if you have to do one yourself, I call it the bracket rule. So if we're asked to differentiate 7 times 2x squared minus 5x plus 3 all to the power 6, I treat the bracket as if it's a single letter and differentiate it. Then multiply by the bracket differentiated. So y equals 7 into 2x squared minus 5x plus 3, all raised to the power 6. I treat everything in the bracket just as if it's a single letter. So that gives you dy by dx is 6 times 7 times the bracket to the power 5. But then you have to remember to multiply it by the differential of what's in the bracket. So you differentiate what's in the bracket. Now that's 2x squared becomes 2 times 2x, and minus 5x becomes minus 5. And so we have dy by dx is 42 into 2x squared minus 5x plus 3 all to the power 5 times 4x minus 5. And so dy by dx is equal to 42 into 4x minus 5 into 2x squared minus 5x plus 3 all to the power 5. Well, I would generally write it out as I've done in example 2 using the chain rule, but you can try and work out how to do it quicker than that. Now note, this doesn't help us with brackets like 3x squared minus 4x plus 5 all times 2x cubed minus 6x plus 3. Or it doesn't help you with x squared minus 3x plus 2 all over x cubed minus 7x. Those can't be done using the chain rule. But we will learn some other rules, the product rule and the quotient rule, for when we've got questions like these.